Hiya folks, this is a video about polar forms, so it's how to put a complex number into polar form. So the example is to express -1 plus I root 3 or root 3i in this form. So this is what's called polar form. So the r, that's just the modulus. So if you don't know how to do modulus, then look back, but that's just, so the r part will just be square root of -1 squared plus root 3 squared. So that's just going to be 1 plus 3. So that's square root of 1 plus 3, so the square root of 4, which is 2. So r is 2 here. So we know that we're going to be putting in a 2 in instead of the r. The theta then is the other thing to work out. So I'm going to draw it just to help see what it looks like. So this is on the Argand diagram. So it's -1 plus I root 3, so we're going to have to go across to -1. So we'll just say -1 is there, and we'll say that root 3 then, doesn't really matter, we'll just say it's up here. Right, so what we have to do is, it's always from here that we have to find the angle. So we want to find this angle, and theta. So we're going to put whatever that angle is in instead of theta here. So we need to work it out. So we see that the distance from there is going to be root 3 because we're going to cross -1 and up root 3, and the distance along the bottom is going to be 1 because we've travelled 1 across the bottom to get out to -1. So I'm going to get the tan, it'll always be tan. So I'm going to do tan inverse of, in order to work out this angle, it'll be the opposite, which is root 3, over the adjacent, which is 1. And that will give me what it is. And if you put your calculator in radian mode, it'll give you, just make it easier, as that's what we wanted in for this. And we'll get pi over 3 when we put it in. So that little angle in there is pi over 3. So a couple other things you need to know. So basically from there to there is always going to be pi, because we know that a whole circle is 2 pi r, that's the circumference. So the whole distance around there is pi. Therefore, if the little orange angle there that I found is pi over 3, well, in the red angle, which is the one I really want, it has to be 2 pi over 3. Because 2 pi over 3 plus pi over 3 would make up pi. So therefore, my theta in this question is going to be 2 pi over 3. So my final answer is going to be 2 cos of 2 pi over 3 plus I sine 2 pi over 3. And that's my final answer. So that's the polar form then of that complex number. So here's another one if you want to pause the video and have a go at it, and then play it on, and I'll go through the answer. So the first thing anyway, to get r, we're going to do -2 squared plus root 2 squared. That's going to be 4 plus 2, and that's going to be root 6, so we'll leave it as root 6. Now again, I'm going to go and draw this. So you have to go across to -2, so we'll say that's -2, and up to root 2. So let's say it's about here. And again, I'm going to use, I'm going to find this red angle here. So that would be, well, that's going to be root 2, that's going to be that's going to be, the distance from here to here is 2, because I have to go across to -2. So I'm going to do tan inverse of opposite over adjacent, so root 2 over 2. Now for this one, it's not working out nicely on the calculator, so it gives me 35.3. That's in degrees. So I put that in there. So if you leave this one in degrees, then if you do 180, take away 35.3, it'll give me just this bit, which is the one I always want. So that's theta, and I'm going to get theta is equal to 144.7. So in polar form, then it's going to be root 6 cos of so I'm leaving it in degrees here is easier, but generally you're looking to use to get it in radian form, to get pi over something, or just in terms of pi. So that's it.